Hello everyone, and welcome to Automotors TV. Today we're diving deep into one of the most fascinating aviation concepts to hit the internet recently, the futuristic HA-420 fighter concept attributed to Honda for 2026. Before we begin, a quick note, this script treats the HA-420 as a speculative, fan-made concept built on the HondaJet legacy. It's a creative vision, not an official military program. With that said, let's explore every detail, design, performance, systems, mission roles, and what this kind of aircraft might mean for the future of aerial warfare and aviation technology. Imagine approaching this jet for the first time. The silhouette is at once familiar and otherworldly. It borrows the hallmark over the wing engine placement that made the HondaJet unique, but the airframe has been reshaped into a low observable, highly swept design. The nose is sharply raked, the canopy is frameless and blends smoothly into the fuselage, and the fuselage itself flows into an almost blended wing configuration, sculpted to manage radar reflections and reduce drag at high speed. The wings are moderately delta-shaped with a slight anhedral at the tips, and the trailing edges are serrated inboard near the flaps, a subtle nod to radar cross-section control. The twin vertical tails are canted outward and trimmed with small fairings that hide sensor suites and electronic warfare apertures. Overall, the aircraft reads like a compact, agile stealth fighter built for speed and agility without sacrificing the efficiency Honda is known for. Under the skin, the concept imagines a hybrid propulsion philosophy. Twin next-generation turbofan engines sit above and slightly behind the wing roots, protected by carefully shaped inlet ducts and S-shaped intake channels to shield compressor faces from radar. Exhaust nozzles are vectored, not necessarily full 3D thrust vectoring like the most advanced fighters, but a degree of thrust vectoring sufficient to enhance pitch authority and short field performance. These engines are conceptually designed to optimize a balance between supersonic dash capability and cruise efficiency. Think of sustained transonic cruise with the option for short supersonic bursts, a design philosophy that reflects modern multi-role needs, fast ingress and egress, but not the fuel penalty of continuous high Mach operation. A key pillar of the HA-420 concept is advanced flight control and autonomy. An integrated AI-driven flight control system runs high-fidelity sensor fusion, combining inputs from inertial measurement systems, distributed MEMS sensors, and a redundant fiber optic gyroscope network. The AI augments the pilot's inputs, reducing workload during complex maneuvers, automating threat responses, and assisting in formation flying or swarm tactics when multiple assets are deployed. The concept even imagines optional unmanned or optionally manned missions, where a highly trained human pilot can hand off control to the AI for high-risk phases, or vice versa. This hybrid man-machine approach plays into modern discussions on survivability and decision speed in contested airspaces. Avionics in this concept are modular and open architecture. A panoramic cockpit display with augmented reality overlays provides the pilot with synthetic vision, threat envelopes, and fused targeting information. Helmet-mounted cueing complements the cockpit, allowing pilot gaze to direct sensors and weapons. The radar is an active electronically scanned array, AESA, with advanced low probability of intercept modes. But it's not just radar. The aircraft carries a distributed aperture sensor network that provides 360-degree situational awareness, infrared search and track, and missile warning functions. Electronic warfare capabilities are integrated, with onboard jammers, expendable decoys, and cyber-hardened data links. Essentially, the HA-420 concept treats electronic dominance as equal in value to speed and stealth. Weaponry is where the concept truly plays with flexibility. Rather than a single huge internal bay, the HA-420 concept imagines multiple modular internal and conformal bays for a mix of air-to-air missiles, small precision-guided munitions, and directed energy modules for defensive use. Internal carriage preserves stealth signatures for initial ingress, while external hardpoints can be used when stealth is less critical. The idea of a small, highly agile fighter carrying a mix of long-range missiles, short-range sidewinders, and networked loitering munitions opens new operational possibilities, a small platform that can operate with larger platforms as a force multiplier or independently as a low-cost, high-agility defender. From a materials perspective, the conceptual HA-420 applies Honda's experience with lightweight structures and composites. Advanced carbon fiber composites, ceramic matrix components in high-temperature zones, and shape memory alloys for control surfaces are featured. Add to that radar-absorbent materials where they matter most and thermal signature management in the engine exhaust, and you have a platform focused on reducing detection from multiple spectrums: radar, infrared, and visual. Let's talk performance numbers, framed as conceptual estimates, not hard facts. The HA-420 fighter concept could be imagined to have a top speed in the vicinity of Mach 1.6 to Mach 1.8 in a clean drag configuration, with transonic cruise around Mach 0.95 for fuel efficiency and long-range loiter capability. Acceleration and turn rates would be emphasized through the combination of thrust vectoring and advanced flight control laws, making the jet extremely responsive in short-range engagements. Range would be competitive, internal fuel optimized for several hundred nautical miles of combat radius with external tanks for ferry missions. Again, these are speculative figures meant to help viewers picture capabilities, not claims of actual performance. Operationally, how might this aircraft be used? One concept is distributed air defense and localized air superiority. Smaller, less expensive fighters can be deployed in larger numbers, operating from austere airstrips or roadways. Because the HA-420 is compact and efficient, it could be used as a rapid reaction fighter for island defense, littoral operations, or as an escort for larger assets. Its modular payload allows mission swapping within hours, turning a strike-configured jet into an ISR platform or an electronic warfare variant. The optionally manned capability expands mission flexibility. High-risk suppression of enemy air defenses, SAAD, missions become plausible without risking a pilot's life, or the jet could perform long-duration reconnaissance runs under AI control. Pilot experience is central to any such concept. Imagine climbing into a cockpit designed for situational clarity. The seating is ergonomically tuned, visibility is optimized through canopy design and augmented overlays, and the human-machine interface is smooth, with tactile feedback on primary controls and a neural-friendly display environment. The pilot's role evolves from stick and throttle manipulation to tactical decision manager, authorizing AI-managed maneuvers, prioritizing targets, and managing collaborative tasks with wingmen and unmanned drones. This evolution reduces fatigue, increases mission endurance, and speeds decision-making, a crucial advantage in contested, sensor-rich battle spaces. What about production and logistics? A modern fighter concept like this would likely embrace digital engineering and additive manufacturing to accelerate development and keep costs down. The use of modular avionics and common subsystems across fleets simplifies maintenance and training. Honda's industrial expertise in precision manufacturing could theoretically translate to tighter tolerances and efficient production lines. Still, turning a concept into a production fighter involves enormous hurdles: certification, weapons integration, supply chains for specialized materials, and political decision-making about procurement and export controls. In short, while a concept may be technically intriguing, real-world adoption is subject to many economic and strategic constraints. There are also ethical and geopolitical questions. An optionally manned jet raises debates about autonomous engagement decisions and the legal frameworks governing them. Export of advanced fighter tech is always tied to geopolitical relationships and treaties. A hypothetical HA-420 in production could shift regional balances if deployed strategically. The integration of AI in lethal systems would spark fresh debates on accountability, rules of engagement, and how much autonomy should be ceded to machines in life and death scenarios. Now let's consider how this concept changes air combat doctrine. Instead of relying solely on a few expensive, high-end fighters, air forces might mix smaller, cheaper, and more numerous platforms with larger flagship aircraft. This distributed approach complicates an adversary's targeting calculus and increases resilience. Losing one or two small fighters is more manageable than a handful of expensive heavyweight jets. In networked operations, small fighters equipped with advanced sensors could feed data into a broader battlespace picture, acting as eyes and light strike assets in a very agile, responsive force. Critics will, of course, point to limitations. A smaller airframe has less internal volume for fuel and weapons, limiting payload and endurance compared to classic heavy fighters. Achieving stealth in a small platform has trade-offs: sensor aperture sizes, heat dissipation, and internal carriage constraints all present design challenges. Moreover, High-performance engines that permit supersonic dashes tend to be fuel-hungry and expensive to maintain. Those trade-offs define the design space and force engineers to prioritize mission requirements carefully. So what might the timeline look like if a manufacturer like Honda, hypothetically partnering with defense contractors, pursued such a project? Concept design and simulation could progress quickly thanks to digital twins and rapid prototyping. Ground testing and flight demonstrators would follow, ideally within a few years, but full operational capability typically takes a decade or more once development begins. And of course, certification and integration into an Air Force's doctrine and logistics chains add complexity. The timeline from eye-catching concept to operational fleet is long, expensive, and unpredictable. From a cultural standpoint, the idea of non-traditional aerospace manufacturers entering the fighter market reflects a larger trend: cross-industry innovation. Automotive companies bring strengths in manufacturing efficiency, supply chain optimization, and mass production techniques. Aerospace partners bring experience in survivability, weapons integration, and military certification. The cross-pollination could lead to interesting hybrid programs where nimble, cost-efficient platforms augment traditional aerospace giants. Finally, what does this mean for enthusiasts, modelers, and content creators like us? Concepts such as the HA-420 spark imagination. They challenge our assumptions about what a fighter should look like and do. For content creators, that's golden. You can explore not just the machine, but the human, industrial, and geopolitical stories that surround it. When discussing speculative designs, emphasize the creative and visionary aspects while being transparent about the fictional nature of the concept. That approach keeps your audience engaged and informed. Thanks for taking this extended journey through the HA-420 concept with us. If you enjoyed this deep dive and want us to expand any section, maybe a full technical breakdown of the avionics, a pilot POV walkthrough, or a speculative cost and production analysis, let us know in the comments. Don't forget to like the video if you enjoyed it, share with fellow aviation fans, and subscribe for more future tech and vehicle deep dives that blur the line between reality and imagination. This is Auto Motors TV, thanks for watching, and we'll see you in the next video.